So please look at the current problem of a given function f of x. You need to find all the local maximum points and local minimum points. And moreover, you need to tell me where is the function increasing and decreasing. And both problems can be solved by using the sign table of f prime. And let's do it for the f prime first. So f prime of x based on this current function, which is a product of two functions. We can actually use the product rule to find the f prime of x. So by the product rule, what you have is the following. We can differentiate the first function square root of x first. So it is actually 1 over 2 times square root of x. And we can keep e to the power minus x unchanged. And for the next term, we keep the square root of x unchanged. And the derivative of e of minus x is a mini application of chain rule. So it is minus times e to the power minus x. And let's simplify it a little bit. We notice that we can pull out the common variable, which is e to the power minus x here. So we get that e to the power minus x times open bracket 1 over 2 times square root of x minus square root of x, right? And let's do an algebraic manipulation here because I think we can use a common denominator 2 times square root of x here. So if I write it this way, the first term in the numerator is still 1 because I'm just copying the 1 here. For the next term, we need to multiply the top by 2 times square root of x because I'm expanding the denominator here, and then we understand that the item inside the bracket is going to be 1 minus 2x divided by 2 times square root of x. And please notice that we are trying to find the critical number here. So let's try to set f prime be 0 and see what's happening to find the critical numbers. And please notice that the first factor, which is e to the power minus x, cannot be 0 at all for all x. Because if you look at the graph of this function, y equals e to the power minus x, the graph is actually like this. It will never touch the x-axis, never. So it means that there's no x-intercept available for this graph, which means that there's actually no answer to the equation e to the power minus x equals 0. And which means that for such equation, to solve it for x, we need to look at the second factor instead. We need to look at the second factor instead, and let's look at this current fraction now. And for a fraction to be 0, the obvious one is we can make the numerator 0. So it means now to solve it, x becomes 1 over 2, right? So it is obviously a critical number, but please think about it for a moment to see if there's other possibility of critical number. Because by the definition of critical number, when the f prime is undefined, for the certain values of x, we still call these values of x critical numbers. And if you look at the f prime at the top here, can it be undefined? The answer is yes. So numerically speaking, it looks like when x is 0, we understand that f prime would be undefined. However, let's go back to the original function f. For the original function f here, you see, what is the domain of this function? Based on the property of square root, I mean, because for the square root of x, x can only be non-negative. So we understand that for this function, the domain is actually x at least the same as 0, at least. And you see, this x equals 0 numerically will make the f prime undefined. But this point is not that important for understanding our problem, because now the x equals 0 is kind of like the boundary of the domain, because our domain contains all the points starting with 0. And anyway, it means what? It means when we draw the sign table of f prime, this x equals 0 is not that important because it's like the boundary point of the domain, and it doesn't give us any special information. So next point is we need to draw the sign table of f prime. So we can look at the current sign table for f prime, and the red part is cancelled out because we don't have to look at those points which are not in the domain of x. And moreover, we have only one critical number as we noted before, so which is 1 over 2, 0.5, and you need to do the sign table based on the two intervals here. So you see on the two intervals, you have to randomly choose some points. For example, you can choose maybe f prime of 0.3 for the left interval. For the right interval, you can choose maybe f prime of 1. And let's do the numerical calculation of these 2 points. Then you would see that the f prime of 0.3 is actually positive, and the f prime of 1 is actually negative. So I'll mark them here for the sign of the f prime. And positive f prime means we can draw an arrow which represents the tangent to be an increasing tangent, like going up, and the downward arrow representing that the tangent direction is going down. So with this sign table, we can actually write the answer to this current problem. So you see, to this problem, we don't have any local minimum, but we have one local maximum. Because around the point 1 over 2, we understand that the function looks like it is increasing first and decreasing, right? So we have only one local maximum. So we'll put it here. Local maximum would be the point when x is 1 over 2. And the y coordinate of this point is f of 1 over 2. And f of 0.5 is the same as square root of 0.5 times e to the power minus 0.5. And for the numerical answer of it, you can easily do it by calculator. We don't have to mention that. And the last question of this problem is that we need to find where is f increasing. So f of x is increasing when we are in the interval from 0 to half, 0 to half. And similarly, f of x is decreasing for the interval starting from the point half. So which means it is the interval half until infinity. So that's the final answer to this problem.